Hello everyone. Today class number 13 for your electrical machine 2. So class number 13. Electrical machine 2. Okay. So today I will discuss the operating principle of three-phase induction motor. Operating principle of three-phase induction motor. Okay, so write some points. First point, three-phase balanced supply. Three-phase balanced supply are given to the three-phase stator winding. Second point, it makes a production, right? It makes a production of rotating magnetic field. In air gap. Okay. Third point, so that is three-phase fluxes and three-phase balance supply is given. Second point, it makes a production of rotating magnetic field in air gap. And third point, right, there are the armature conductors. There are the armature conductors in which the rotating field makes, in which the rotating magnetic field is linked with fourth point, according to the Faraday induction principle, any time varying field can induce an EMF. Any time varying field can induce EMF in the conductor which are linked with it. Okay, thus the armature conductor, across the armature conductor there will be an EMF generated since the armature conductors are short circuited, are either short circuited by end rings or connected through slip ring arrangement, there will be a path of current flow through them, through the conductors, through the armature conductors. That means what? A three-phase system can produce a rotating magnetic field inside the air gap, and this rotating magnetic field is linked to the armature conductors, and since the armature conductors are short-circuited, either short-circuited or connected through some slip ring arrangement, then a circulating current will flow through it, right? A circulating current is flowing through it. And next, the armature conductors are now become current carrying conductor, which are placed in magnetic field, right? The above situation results, right? The above situation results a rotation in the armature conductors, right? There is a above concept is produces a rotation in armature conductors. Now, right, armature conductors are housed in the armature slots, so the armature also rotates, so the total armature also rotates according to Fleming's left hand rule. Okay, according to Fleming's left hand rule. And last point, output can be found. That is, output means what? In terms of torque and speed. Right? So output can be found from the shaft connected to the armature, in the form of mechanical energy. Okay, so from the three-phase input to the mechanical output, there is a lots of points are there which speaks the basic principle of operating principle of three-phase induction motor. Okay, so this is all about your three-phase induction motor concept. So now I will move into the power flow diagram and torque expression. Okay. So So now write EMF equation. EMF equation of three-phase induction motor. Right. A three-phase induction motor produces a rotating magnetic field by which the rotor part linked to it to rotate itself, right? So there is a magnetic field traveling. From stator to rotor through air gap, which is very much similar with the single phase transformer short circuited for secondary terminals. With single phase transformer short circuited by secondary terminals. That is the EMF equation, that is the EMF generated by three-phase induction motor. Will seems to be same as of the EMF in single phase transformer, that is E equals to 4.44 F phi m n, right? So this is for your transformer concept. Now I am writing it for three-phase induction motor, so it will be kW will be here. So E equals to kW into 4.44 into F into phi m into ns. Okay, so write where kW equals to winding factor, F equals to frequency of three-phase supply system, phi m equals to maximum flux generated by stator field, that is peak of the flux. Okay, and ns equals to synchronous speed. Okay, and now elaborate this winding factor. In your first module, this winding factor is already have been taught, right? So this winding factor is nothing but coil span factor into distribution factor. Okay, coil span factor into distribution factor. Okay, so formula will be written in first module. Please see over here, over that. So refer to the first module. So this Kc and Kd or Kw concept will refer to module 1 or unit 1. Okay, unit 1. Okay, so ultimate, this is the EMF equation for three-phase induction motor. Okay, now the power flow equation. So how the power will flowing from input side to output side, and where, and there are different types of losses are there, so we have to collect it in a compact manner. Power flow equation. input to the three-phase winding in terms of electrical power. Okay, so from stator there are two types of losses, that is I square R loss called PC, that is copper, PCU, that is copper loss. Okay, and second one PI called iron loss. Okay, so from this rotor there is also I square R, so let us consider I1 and I2, and it is R1 and R2. Okay, so I2 square R2 loss, that is PCU dash, it is rotor copper loss, rotor copper loss. Okay, rotor copper loss. And from the rotor there is another type of loss which is called the winding plus friction, winding plus friction loss. Okay, so there are lots of losses are there. So and the power will coming into input, so let us consider PI, input power, and here the power after output it will be P1 suppose, and after, so this is your P1. Okay, and rotor, after outputting the rotor it will be P shaft speed, PSH, or finally it is PM, mechanical output. Okay, so actually PI equals to P1 plus I1 square R1 plus PI. Okay, then PI can be again divided into P of winding, that is winding plus friction loss, P of W, I think. Okay, so PW plus PSH plus PI2 square R2 plus I1 square R1 plus PI. Okay, so finally this PSH equals to PAM. Actually mechanical output will be equals to the shaft output, as we are considering the winding loss is in from the rotor. So once in and sometimes it will considered from the shaft also. So from the shaft you can also write PW. Okay, so once it is written in here, so no need to write over here. So if we want to write over here, so no need to write over here. Okay, so this is your formula. PI equals to, oh sorry, it will be, suppose it will be P input, PIP. Okay, PIP. So make it PIP because PI is coming into here. So actually PIP, so output will be P shaft power will be the output power, or PSH can also written as PM is also written as P output. Okay, so P output equals to P input minus these losses, that is PW plus I2 square R2 plus I1 square R1 plus PI. Okay, okay, so this is the concept of your power flow equation. And now I will move into the equivalent circuit of three-phase induction motor. The equivalent circuit of three-phase induction motor. So three-phase equivalent circuit of three-phase induction motor is nothing but, as we know, it is very much similar to the single-phase transformer. So right, as we know, the three-phase induction motor is looks like or similar to the single-phase transformer according to the operating concept. According to the operating concept, then the equivalent circuit also looks like similar to that of the single phase transformer. Okay, and secondary is short circuited, right? And so secondary is short circuited, and it is given, and it is per phase, right? This equivalent circuit is per phase equivalent circuit. Okay, remember it is a per phase equivalent circuit. So this is your R1, I1, X1, and it is your Rm, this is your Xm or Re you can say, and this is your I naught, and this is your I1 dash, and here it will be E1 is generated, here it will be E2 will be generated, and from here I2 current is flowing, R2, X2, and the secondary terminals are short circuited, that is ISC equals to I2. Okay, so this is your VPH, per phase, the phase voltage. So VPH equals to per phase voltage input to the motor. Okay, and R1 equals to stator part resistor, X1 equals to stator part reactor or stator part reactance, and I1 equals to stator part current, Re equals to excitation resistance or the resistance offered by excitation system, and Xm equals to reactance offered by excitation system, and similarly I2 equals to rotor part current, I2 equals to rotor part current, R2 equals to rotor resistance, and always remember all the terms are per phase. Okay, these are per phase. Okay, and X2 equals to rotor reactance, and E1 equals to induced EMF at stator, and E2 equals to induced EMF at rotor. Okay, so this is all about your equivalent circuit. So next day I will start the phasor diagram of by the concept of equivalent circuit. So please wait for the next day. I will start the next day. Okay, so today's class up to this much. Thank you.